Right, so uh, I hope you guys found the Arduino practice fun. I think it is. But now I'm going to explain a little bit the theory behind it. I know that most of you guys were able to connect it and most of you guys were able to make the code work. But now I want to draw the schematics of actually what you guys did, the circuits that you guys did. Um, so before we do that, I want to give you a little bit of a how do you say this? A little bit of background in terms of electronics, and I want to show you the symbols that are normally used in electronics. And the ones that we used were resistor. So this is a resistance. This thing right here is an LED. Light, this stands for light. Emitting. I think it's double T. Sorry if it's incorrectly spelled, I'm not sure. Light emitting diode. Okay, this is what an LED is, and we have a, well, let's say a voltage source. So let's call this voltage source like that. Okay, something like that. Okay, this is voltage source. So the simple LED circuit that we did was this one right here. This was the simple LED circuit that we did. Okay, um, and remember that I told you that, remember that you guys had to connect a resistance in between the Arduino and your LED. Okay, so our Arduino is going to be a voltage source. Yeah, I'm gonna start with that. The output pins of our Arduino are going to be voltage sources, and we're the thing with the Arduino is that we are going to be controlling at what times does this voltage source work and how much voltage is going to be sending out. That is basically what the microcontroller is. It's a voltage source that you can control. Okay, so this is not like a battery that you just connect and it works indefinitely. It's rather a voltage source that you can program to give out voltage at different intervals and different times. Okay, that is basically what the Arduino is, a programmable voltage source. At least we're going to be looking at it like that for the following weeks. So this is the Arduino. Well, one of the pins that we use, I think it was pin 13. So pin 13 is our voltage source, and we created this circuit with a resistance and a LED. Remember that this part would be the negative, this part would be the positive. So pin number 13, the output of pin number 13 is here. And this part right here, the negative, is called the ground. Okay? Another way to look at this, how do you say? Now, let's continue with this one. Let's continue with this one. So, remember that we put a resistance right here. The thing with that resistance is that because of Ohm's law, we need this resistance right here to generate current. Why? Because the an LED has no internal resistance. Has no resistance. So since this LED has no resistance, uh, without the resistance here, an equivalent circuit would be something like this with the LED right here. Okay, this is a voltage source. So without the resistance, this same circuit would be this one right here without the resistance. But since this LED has no resistance whatsoever, this circuit would be something equivalent to this. To just a voltage source, okay? Just a voltage source. And this, of course, doesn't have any current. So in this case, there would be no current. Why? Because there is only a electro motor force. There's only an electromotor force source. So the voltage source is right here. Imagine it as being just a motor, but it doesn't have actually anything to push right here. Okay, because there is no current. Remember that through Ohm's law, voltage is equal to I times R. So voltage divided by resistance is equal to current. If there is no resistance, then there is definitely no current. Okay, no current whatsoever. No current whatsoever. Okay, so that is why we need to add an external resistance. So once we add something like this into our circuit, okay, we have something like this, and now we have some sort of voltage and we have some sort of resistance, and therefore we will have some current flowing around this circuit like that. Okay? So that is why we need to put resistances in our circuits. Well, basically because we want to regulate how much current we want to flow within the circuit. If we were to use a bigger resistance right here, if we were to use a bigger resistance here, look at what would happen to the current. This number is fixed and this number increases. If this number increases, then you would have a smaller current. The higher your resistance would be inside this circle, the smaller the current that you would have. Okay, so we could regulate how bright the LED is shining by regulating the resistance that we have here. A low resistance would have a very high current, therefore we would have a very bright LED. A very high resistance would have a very low current and we would have a dim LED. Okay, so that is basically what we did with the one circuit. Now, let's figure out. Let's figure out. Let's see how we did the semáforo. Okay, so let's do that. Let's have our Arduino again, right here, and this guy is a voltage source. Okay, so out of pin number 13 came a circuit, an LED, and this thing went down here. So positive, this is pin number 13. Voltage comes from here, and it goes into the ground. And we have this circuit right here. So this would be the, well, you know what? I'm gonna redraw it with the appropriate colors. So something like that. This would be our red LED, like that. Okay? Let me draw it a little bit smaller. So this is pin number 13. And we end up in the ground. Oh, another symbol that we're going to be using right now is this one. This one indicates ground. Okay? So we have our pin number 13 on our circuit in pin number 13. Then we have out of pin number 12 a similar circuit. Well, not similar, the exact same circuit. And we also go into ground again. But this one is coming out of pin number 12. And finally, we have our green light circuit coming out of our voltage source, which is our Arduino, and let's say it came out of pin number 11. This thing, we can rewrite it. We can rewrite this, instead of putting all of these circuits like this, we can rewrite it like this. We have our voltage source. Our voltage source is connected to the ground, like that. And we can have our green circuit, like this, connected to the ground as well. We have our yellow circuit connected to the ground as well. And we have our red circuit connected to the ground as well. Okay, so this ground symbol, is as if we were connecting all of these things to the same point, to this point right here. Okay, but instead of making big loops, okay, instead of making all of these big loops like this one, we just decide to say reference all of these points to the same position, which is ground, which is the negative lead of our Arduino. Okay, like that. So of course we will have, due to this resistance and this voltage source, we will have this current right here. So let's call this I1. Due to this resistance and this voltage source, we would have another current here. This is called I2. And due to this resistance and this voltage source, we would have I3. So this is actually the circuit for our semáforo, okay? This is basically the circuit that we have. This is the Arduino. Let's say that this is pin number 13. Let me put it all in purple. Let's say that this is pin number 13, this is pin number 12, and this is pin number 11, right? So we have each of the pins is a voltage source, okay? We are going to be programming pin number 13 with some voltage, pin number 12 with another voltage, and pin number 11 with another voltage, all of them coming out of my voltage source, which is my Arduino, okay? So that is basically it. This is basically how our circuit works. We would have to, of course, declare, we would have to declare with this function, pin mode, we would have to declare pin number 13 as output. We would have to declare pin number 12 as output. And we would have to declare pin number 11 as output. Because you're telling the Arduino that these three pins are going to be used as voltage sources, outputs, okay, voltage sources. If you decide to use pins as inputs, as they are like voltage readers, they would read some voltage or they would read some current, and that is something that a sensor will be giving. But we'll go into that next week. So what else? What else? Oh, and then you would have to program, okay, you would have to say that this pin is in high for some seconds and then turn it off by setting it in low, then setting this pin in high and then setting it in low, and then this thing setting it in high and then finally setting it in low. So that is basically the circuit explained. I hope you guys understood all of this circuitry. And well, I'll upload another video. And thank you for watching. Bye.